All right, let's do another example in 11.8. This is example number 2. It says a furniture builder is designing a rectangular end table with a perimeter of 128 inches. What is the maximum area that the table will hold? What dimensions will yield that maximum area? You notice that I've highlighted a couple keywords here. We're trying to find the maximum of something, right? And so if I can make a parabola or get a quadratic equation, I should be able to find the maximum value as long as I can find its vertex. So we have to be able to read through this problem and set up some sort of an equation where I can find the maximum value, the vertex of our parabola. So what couple things are we talking about here? Well, I know that one of the things it was talking about was, first of all, that this end table was a rectangle. So I kind of imagine what a rectangle is. On a rectangle, I have length times width. And it was also talking about the perimeter of this rectangle, right? It told us in the problem that the perimeter of our rectangle was 128 inches. Hopefully you know that perimeter means length plus width plus length plus width all around the outside, right? So let's go ahead and first talk about perimeter. If I was adding up the length plus the width plus the length plus the width, I know that it's supposed to equal 128. Now I don't know what the dimensions are, the length or the width. That's actually part of what we're trying to find, right? But what I can do is set up an equation that talks about the perimeter, length plus width plus length plus width, or 2L's plus 2W's, is supposed to equal 128. In that equation, unfortunately, there's two variables. There's an L and a W, right? And I can't really solve if I have two variables in the problem. So we're a little bit stuck. Plus, we're not asked to find the maximum perimeter, we're asked to find the maximum area. So really what we're concerned about in this problem is the area, not really the perimeter. We want to find the area's maximum. So we need an equation that talks about the area. Hopefully it's quadratic, so it looks like a parabola, so that we can find the maximum area. So let's go ahead and talk about area. We don't really know what the area is, right? We want to find that maximum area, but we do know that the area of any rectangle can be found by doing length times width, right? Okay, but here's another problem. In our area equation, we also have L's and W's, too many variables. Actually, we have 3 variables. Don't we have an A and an L and a W? We don't know what the length is, we don't know what the width is, and we don't know what the area is. We have way too many variables to solve. So what we're going to do is we're going to go back to the perimeter equation. We're going to solve that equation for one of the variables and then use it to substitute in to the area equation. Because remember, that's the one that I'm really concerned about, the area. So let's go back to the perimeter equation. Let's go ahead and solve it for W. So I'm going to subtract 2L to both sides so I can get it to say W equals. You can do it for L, you could do it for W. It won't really matter. We should have the same answer in the end. I just chose one, W, and I'm going to try to isolate W, get W by itself. After I subtracted the 2L from both sides, I ended up with the equation 2W equals 128 minus 2L. I'm going to get the W all by itself by getting rid of that 2 and dividing every single term by 2. So I ended up with an equation that says W equals 64 minus L. Now, since W equals 64 minus L, I can use our idea of substitution and plug in a 64 minus L wherever I see a W in my area equation. So I'm going to take out the L, leave everything else, and I'm going to plug in take out a W, I meant to say, and leave everything else and plug in a 64 minus L instead. So it should look something like this. I still have the A equals, I still have the L, but then instead of W, I'm going to substitute in 64 minus L. Do you notice that it then eliminates one of my variables? So now all I have is L's and A's. If I distribute the L through, I end up getting A equals 64L minus L squared. If those were X's, I would have an X squared and an X. And if I were rewriting it in a different order so that the L squared was first, it would look something like this. Doesn't this kind of look like a quadratic? If you're more comfortable and use y's and x's, it would look something like this. Y equals negative x squared plus 64x. That's a quadratic. I know that that is going to be a parabola. I know that because my leading coefficient is negative, my parabola is going to open down, which means I'm going to have a maximum. And isn't that what we're trying to find? If this equation represents the area and I want to find the maximum area, well, I want to find that top spot right there. the vertex. So I should be able to use this quadratic equation for my area, and I should be able to find the vertex. I should be able to do negative b over 2 times a. In this case, a is -1, right? That's the invisible -1 in the front. B is 64. Now c is there, it's just a +0 if you needed to write one. But really all we need in order to find the vertex is -b over 2 times a. So that's what I'm going to use. I have a -64 over 2 times -1. I end up with a -64 over -2. Two negatives, when I divide, make a positive, and I ended up getting L equals 32. So I know that the length, in order to have a maximum area, has to be 32 inches. Now, the question didn't really ask us for just the length. Didn't the question actually ask us for both dimensions and what the maximum area is? So I need to make sure that I answer all pieces of my question. I know that in order to get a maximum area, I need the length to be 32. So if the length is 32, what would the width be? Well, you notice that I should be able to take the length, L equals 32, and plug it into my equation for width. I should be able to find W by replacing the L with a 32. So 64 minus 32 is 32. So I need the length to be 32 inches. I need the width to be 32 inches in order to have a maximum area. That's my vertex, right? All right. It also asks us for the maximum area, and we know that area is length times width. So in order to figure out what the maximum is, well, if I need the length and the width to be 32 inches each in order to have a maximum area, I can multiply them together and say that my maximum area is going to be 1,024 square inches. I found the length and the width. That's going to give me a maximum area because I found that vertex of my parabola. I multiplied those together to figure out what the maximum area was. So really, if you look at it, it's actually not going to be a rectangular end table, is it? It's actually going to be a square rectangle, but that square rectangle is going to give us the maximum area possible. All right, now that we've done that question together, what I'd like you to do is I'd like you to pause the video, write down this question, and maybe try this question all by yourself. Kind of using the same idea that we just did with perimeter and area. See if you can find the dimensions of the garden that will yield the area that is the maximum on this one. So pause the video, write it down, try it, and let's see how far you get. So in this problem, it says that Ginger is fencing a rectangular garden using the side of her house as one of the sides of the rectangle. What is the maximum area that she can enclose with 50 feet of fence? What should the dimensions of the garden be in order to yield this maximum area? So a keyword there is maximum, and I want to maximize the area. So really, I'm most concerned with the area. I need to figure out an equation, hopefully a quadratic equation that turns out to be a parabola, so that I can find the maximum area, right? All right, the problem is I don't know what the length is. I don't know what the width is. I don't even know what the area is. I have an A equals L times W. Way too many variables to solve, and not quadratic yet. So what else do we know about this garden? Well, I know that she's trying to make a rectangular garden. I know that one of the sides is going to be the side of the house. So I don't know about you, it helps me kind of draw a picture. Okay, not a great picture, but a picture, right? I know that one of the sides of the rectangle is going to be the house. So that means I have a length, a width, and a length. Not 4 sides, just 3 sides now. And I do know that she has 40 feet of fence. So if you think about it, fence is going to go along the length, along the width, and along the other length. So kind of like a perimeter, just not all 4 sides, only 3. So on this picture, I would have 2 lengths plus 1 width, and I know that should be a total of 40 feet of fence. She can't go any more than that because that's all she has. So I can use the idea of perimeter and set up a secondary equation. Now I don't want to maximize perimeter. I know what the perimeter is. It has to be 40. I want to still maximize the area. So what I need to use this perimeter equation for is to solve for one of the variables. So I can use substitution, plug it into the area formula, and then use that equation to find its maximum. So on the perimeter formula, I'm going to solve for W. I subtracted 2L to both sides, and I ended up getting W equals 40 minus 2L. That allows me to take this expression, plug it in for W into my area equation, and eliminate one of the variables. When I did that, I got the equation A equals L times 40 minus 2L. I can distribute the L through, and I notice that I have a quadratic equation. If I wrote the negative 2L squared first plus the 40L, I know that this looks like a parabola because I have that L squared in my problem, kind of like an x squared, right? I know that it's going to be a parabola. It represents the area, and so I know it's going to be a parabola that opens down because the negative 2 leading coefficient, and I should be able to find the maximum area by finding its vertex. So let's do that. Let's find the vertex of this quadratic equation by using our formula for vertex, negative b over 2 times a. I have negative b over 2 times a. Negative 40 divided by negative 4 is positive 10, so I know that L equals 10. L, the length, has to be 10 feet in order to get that maximum area out of her garden. The question asks us for both L and the maximum area, or the dimensions and the maximum area. So if I know that L is 10, I should be able to plug in L here and figure out what W is, the width is. If I plugged in 10, I ended up getting that the width has to be 20 feet. The length has to be 10 feet, the width has to be 20 feet, so I can maximize the area of this garden if I only have 40 feet of fence to go around. It also asked me for the maximum area, so we know that area is length times width, so I should be able to multiply my length times my width, and I end up getting a maximum area of 200 feet squared because it's area. So you notice that we had to use two different equations in order to use that perimeter equation, plug it into my area equation so that I can form a quadratic with only one variable, and then I can find that vertex to get the maximum area.